Hello, everybody. Hope you are doing well. Hope you had a great weekend. Little sun here and there. I know I tried to get as much as I could, but we're back. And I just want to talk about what we have to do for the following week. So here are some announcements. Last week, I loved being on those check-ins. It was great to see your faces, even just for a couple seconds. Want to make sure you're doing well and want to make sure that you're understanding what to do. So remember, Google Hangout check-ins, 2 to 3 p.m. every day with Ms. Harwood and myself. And that's right on Google Hangout, and that code is Harwood Science. Remember to check in. You only got to be there twice a week. If you want to come in every day, that's great. But you can check in either on that Padlet or the Google check-in. Okay, grades are being put in. You can still complete late work. It can only help you. So maybe you're bored. Maybe you don't know what to do. Do that old work. It can only help you, folks. Okay, but we're definitely getting that in, and we should be all caught up by Tuesday. All right. So this assignment that we're going over today is going to be due on Sunday. So just like we did this past week, all this work is going to be due on the 11th, and you have the whole week to do it, so you can get it done early. Um, Even though the school building is closed for the rest of the year, doesn't mean learning and connection is closed, okay? So we want to keep this going as long as we can, help you out, not make it too complicated, but still get your science juices flowing, okay? But always, stay safe, check in with us, wash your hands. We got this. All right, so here we go. I just want to go over a quick review from some of the vocab from last week. All right, and these are terms that we do know and love. So, first of all, a wave, a disturbance that transfers energy. Okay, you have this PowerPoint, and I would like you to go back through and kind of just refresh yourself on some of these vocab terms. All right, now amplitude would be like this picture right here, the distance between the highest crest and the resting position of the wave. All right. Then you have the wavelength is the distance between crests or compressions with that wave. All right. And there's a circle. So go back again if you don't know these too well. All right. Next up, we have frequency, the number of times the wave repeats. Let's see how many times you can count this wave. Let me know. You got 2 minutes. Count how many. What's the frequency here? Let me know. Every time it goes over here, count for me how many waves we got. I dare you. Crest, the highest point of a wave. All right, and those are circled right there. Crest is like the crest of like almost an actual wave in the ocean when it gets all foamy, when it starts to turn over, just like that. Okay. Next up, the trough, the lowest part. The trough, that's where like pigs eat and stuff, you know? Right there at the bottom, the trough of the wave. Just, make the one way to test yourself with these terms is, can you draw what these look like? Could you tell your little sibling or cousin or anyone else around you what this is about if they ask you, like, hey, what's a crest? Could you tell them? I don't know. All right, let's move on to sound waves. Now, I just want to go over what we're going to do this week, okay? So, sound waves. The sound that we hear and make pushes matter around us, okay? So, your first job, watch this video. I had a lot of fun making this video. It's only 10 minutes, a lot of stuff going on, but it kind of helps us with the vocab and what's happening in the world of sound waves. Okay, so please have a watch, take some notes on some of those key vocab terms, and go back to it if you're confused about maybe frequency or pitch or how sound can relate to what we're learning. Okay? All right, your first step, watch that video. All right, next, we have some new wave terms. All right, and they're actually kind of simple. Loudness, I don't know if you ever, define this. Some of y'all are kind of loud sometimes, but the strength of a sound. Intensity, the amount of energy carried through a wave. So really, the way we can tell intensity is just like this, where you have a wave that goes up and down, up and down, up and down, not chill, 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 but super, super fast, up and down quickly is high intensity versus these low intensity waves. So intensity is the amount of energy. Like I am pounding on a door. That's super intense, and those waves are strong, okay? But if I'm whispering into a microphone, those waves are not that intense. Decibels, this is how we measure loudness, okay? So you could measure how loud your clap is. You could measure how loud your dog barks, okay? Sorry, I messed up my words. But that's what we can do. All right? So that's also going over in the video. And then pitch. So how high or low the sound seems. So here we have a nice bird whistling a happy melodic tune. That's a low pitch. But then you got this high, crazy, angry bird. That's more of a high pitch. Those are your examples, okay? You can go back to these terms throughout this lesson, okay? Now the Doppler effect, really cool video on this that I made. So I just want to explain this, but also go back and watch that video. Now it's the change in frequency, so the amount of waves that are coming to you from the source. So whatever is making those waves, how those waves get to you changes and makes you hear it differently, even though the rate of those waves are not changing, okay? Got an interesting video on that to help bring that to life. But, you know, it's like if you are at a corner and a car is going past you, they're not changing the volume in the car, but to you, to your ear, those sound waves are changing and makes it sound different, but it's really not. Wow, the Doppler effect. Also, make sure you feel good about these terms, right? We can't be there with you the whole time, but practice drawing them. If you have a question how to draw them, we can talk about it. We can even show you. We can go over it, but check in with us at 2 to 3 p.m. any day, okay? And also, test yourself. Can you tell someone about this? All right, but practice with sound waves on the next slide. So folks, last week we went to this page. So I'm going to show you what you can do with it, and I'll leave these questions to you, okay? You're going to be typing in your answers right there on the Google Slides. But all of these questions have to do with just messing around with this simulation. So we're going to go over to our friends at PhET. We're not doing water, we're doing sound. Click on sound. Y'all, this is so cool. Okay, a couple things. This right here is what creates the wave. You click the green dot to create the wave, and look at those waves being made, right? You can stop that. All right, you can see what it does when no more waves are made. Then you can play the tone, right? So try that out. Hold on, sorry about this. You can change the tone too. So you press the green dot, and then you can change the max of the frequency. What does that do? The amplitude? What does that do? What is that changing? That's for you to tinker around with, okay? But what you're also going to be able to do is change to see, you know, what do the particles look like when we get the waves going, right? What are the particles doing here? Look at that shape. You can even slow it down right there and see what this looks like. Wow. I love the way that we can see the waves almost being made. Okay? You can do both, right? Really interesting stuff that you can control. And also, it's really fun to play this tone. You could probably annoy some people with this sound, so maybe some headphones will be helpful. All right? And lastly, what you can do is if we clear that, just go to waves, we can turn this off, the green. You can go to a view that graphs this and can see, okay, if we just do this, what does this wave look like over time? Notice the amplitude and the strength of this wave, all right? And what happens when you change it? When you change the frequency, when you change the amplitude, what are you noticing, all right? So take your time with this one. It's actually pretty interesting. All right. You can also go back to both the particles and the waves. And this is just showing you, start the wave, do a little tone. It's like if you had a high-pitched sound with a bunch of these particles that are shaking around, you can kind of see these waves. But you can change the amplitude, and that really is kind of crazy. So I won't do that anymore. Okay? So hang out with this Phet, a lot you can do, and I just want you to play around and see how these waves can change. It's like what we did with the water waves, but this is all sound. Okay? You can also feel free to use these tools up here. This is a measuring tape. This can time your waves. And this is pretty interesting. Kind of put this here. It kind of graphs them based on the pressure of the wave. So it's like if you had that sound towards your ear, what is it going to make? So I'll show you what this is going to look like, okay? So I'm playing the wave. I want to graph that too. I don't have to graph it, but let me change the amplitude. I'll turn this on. And then you're going to start to see the changes in pressure based on two different spots in this little wave vacuum. Okay? Pretty cool to tinker around with. All right? Okay, so your job is to mess around with this, but let me go back here. You're going to answer these questions. All right? If you're confused on them, you can ask us in the chat. All right? But also just try your best. Okay, next up. This is a knowledge check based on what we're doing. So we're looking at have you noticed, when it's quiet outside in the winter and there's snow on the ground? Why do you think that is? What is taking up space? How does that sound move, right? We're talking about high-pitched frequency sounds here, and you're going to move this circle, so you'll be able to drag this circle to either of these wavelengths to tell us which one is the high-pitch frequency. And then I want you to really think about the Doppler effect. Explain it in your own words, and then think of a time where you may have experienced the Doppler effect. Okay? Talk about it with us if you're confused. And then lastly, we are surrounded by noise. Okay? Lawnmowers, helicopters, ambulances, cars, and right now it is actually pretty quiet in the world. So we're getting a break. So think about, for me, why is it important to limit noise pollution? What does that do to our animals? What does that do for you? What do you think we can do to help keep noise pollution down? Right? So just think about the ways that noise affects you, if you like it, if you don't like it, and what we can do to help our planet to improve. Okay? So, folks, that's all I have for this week. All right, this is all due the 11th. You can finish this early and relax for science if you want to, or keep on going. Check in at 2 to 3 p.m. Harwood Science on Google Meets. And folks, always please stay positive. We are here for you. If you're having an issue, don't freak out. This is not the end of the world with schoolwork, but we can help you out. But ultimately, anytime. We want to see your faces. It is a pleasure working with you, and have an excellent week and treat everyone in your lives the best you can. All right. Thank you so much. Bye.